Hello, I'm Connell, the CTO at ZAPPAR, and today I'd like to tell you a little bit about ZAPPAR, but more importantly about some of the creative tools we've built to help developers build AR, VR, and MR experiences. But first, a little bit about ZAPPAR. We are a company that's all about augmented reality, and indeed there are two arms to our business. On one side, we have the ZAPPAR HQ team, who build content experiences for some of the world's biggest brands and companies. And on the other side, we have ZapWorks, which is our content creation platform that enables many thousands of developers around the world to build and distribute AR and VR and MR experiences for their customers. So in case you haven't encountered augmented reality before, what it does is it takes the real world around you and adds virtual content into that world as if it was really there. And at ZAPPAR, we're concerned with making that happen on the screen of your mobile phone. So for example, with image tracking, you can take a object, a poster or a business card, or in this case, a menu for a restaurant, and you can add virtual content onto that surface. So if it's a poster for a movie, for example, you might want to attach the video of a trailer. Or in the case of a menu, you might want to have buttons that let you see how the meal that you might purchase looks. And this content can be 3D, so it can sit on the surface, but also pop out into space. It can be interactive. It can have animation. There are lots of content possibilities. Another type of tracking is face tracking. You might have encountered this sort of thing with Snapchat's face filters, for example. With face tracking, what you can do is attach 3D content that follows the user's head as they look around, or indeed attach images to the surface of the user's face. So on the skin, for example, you might attach a tattoo or some face paint. And finally, we have instant world tracking. Now, what that does is let users choose a location in the world around them to place content and then have 3D content anchored to that position in space. So for example, you might have a user position a vase on their coffee table, which they can then look around in 3D space to see how it might look if they were to purchase that vase for that space. I've got a few little videos just to demonstrate these different tracking types. So here we have face tracking. So in this case, a 3D object, in this instance, it's a helmet, is being tracked from my head. And as I look around and change the pose of my head, that 3D model follows me in space. If I move on to the next one, we have, in this case, what we call a face mesh. So what this is a 3D object, but the mesh fits onto the surface of the user's skin and follows that surface as the user's head moves, but also as their expression changes. Now, it's a little bit creepy in this case, just because we're showing just a plain mask, if you like. But normally what you would do instead is use this technology to place a tattoo or face paint or some sort of other decoration onto the skin of the user. And then finally, I have a little video of the world tracking. So here you can see a vase that's been placed into the user's space onto a coffee table in front of them. And as they move their phone around that table, the object stays rooted into a position in the center of the table. So let's talk a little bit about some of the tools that we've created to help developers build this type of content. And in fact, there's two I'd like to talk to you today about. The first is Studio. Now, it's our complete development environment for building 3D AR, VR, and MR experiences. It allows you to import your 3D models just by dragging and dropping them in. You can arrange them into scenes. You can animate those with transitions and baked animations into those 3D models. And you can script your experiences so that you can add interactivity or gameplay type mechanics. Now, the Studio tool understands all of these different tracking types that we've spoken about, but then also lets you publish straight away through our ZapWorks tool. And what that means is as soon as you hit that publish tool, users can access your content straight away, either through the ZAPPAR app or through our technology embedded into your own app, or indeed now it's also possible for users to access that content directly in their web browser without having to download an app. Now, the second set of tools we've got is called Universal AR. Now, it's a brand new set of SDKs that we're providing, and what it does is it takes all of the computer vision technology that we use within Studio and elsewhere in ZAPPAR, but makes those specific technologies available as SDKs for a wide variety of creative tools and platforms. So it really allows you to leverage those tracking types that we've spoken about in ways that weren't possible before. So I'll give you a little bit more information on exactly what I mean by that. So with Universal AR, you can build image tracked, face tracked, and instant world tracked experiences. So those tracking types we've just seen, but you can build them with the tools that you're already familiar with. So for example, if you're a web developer, you may have used A-Frame or Three.js to build 3D experiences for the web. Well, now with Universal AR, you can build augmented reality 3D experiences using those tools and the tracking types that we've just spoken about. We also have SDKs for Unity, which mean you can use the full set of Unity tools and deploy for these different tracking types. And we have underlying JavaScript and C and C++ SDKs that mean if we haven't provided a wrapper for your chosen tool of choice, you may be able to integrate those underlying SDKs yourself. But the most important thing about Universal AR, in addition to this wide variety of creative options, is how well you can and how widely you can distribute that content. So with Three.js and A-Frame, you can deploy your experiences to web, which means the version of Chrome that's been running on your Android users' devices for many years, and a version of Safari that's been running on your iOS users' devices for many years. So we don't require any special browser settings or any special versions of the browsers. These are already on your users' phones, which means the market available for your users to access this content is huge. Then with Unity, you can also distribute for iOS and Android using the usual App Store distribution mechanisms. But the interesting thing with Unity is we also support Unity's WebGL build output. What that means is you can use these tracking types, image tracking, face tracking, instant world tracking, but you can deploy your Unity built experience to Google Chrome and iOS Safari in the same way as you would with these other tools. And it's kind of the first time that that's been possible. Now, in each of these cases, we've tried to make the SDKs and APIs feel like part of their respective ecosystems. So, for example, the Three.js SDK feels like Three.js API should. It has groups, and it has a camera that derives from a Three.js camera. And indeed, the same is true in Unity. And with Unity, if you wish to switch between the different distribution types, so an iOS build, an Android build, and a web build, you don't need to make any changes to your project to accommodate the computer vision running in the browser or in the native apps. It's literally just a case of changing the build platform and building it. Cool, so I thought I would tell you a little bit more about one of the specific tools, which is A-Frame. Now, you may have encountered A-Frame before, particularly if you've built virtual reality experiences targeting the web browser. It's a very popular toolkit for building 3D experiences, leveraging virtual reality. It's also now possible with vanilla A-Frame to build AR experiences, but A-Frame leverages the WebXR API to facilitate this. And that API is only available in the bleeding edge version of Google Chrome for Android, and in fact enjoys no support on iOS whatsoever. However, with Universal AR, you can support both the Google Chrome for many past versions, but also your iOS users at the same time, without and indeed using these different tracking types, so image tracking, face tracking, and world tracking. So you don't need to worry about the compatibility of the WebXR API. It's a much more cross-platform solution. So what I thought I'd do is just show you a little bit about how content is built using Universal AR for A-Frame, just to demonstrate how easy it is. And so the first thing I'll do is I'll just swap my screen share here. So I'm going to instead, I'm going to share this screen here and bring up this code editor. So here I have Visual Studio Code, but of course any of your chosen IDEs works. And I have what is really a standard A-Frame project here. It's an index.html file, so it's a web page. And in here we have just a normal set of HTML. At the top, we import the A-Frame SDK from their CDN, as you would if you were building any A-Frame project. We then add in, of course, our ZAPPAR for A-Frame project, library, I should say. Now, this is hosted from our CDN here, but you can also download that SDK if you wish to bundle it yourself with your project, or it's available in NPM in case you use that package manager, and it supports bundling with Webpack. So let's look a little bit further into this project. So down here, if you're an A-Frame developer, you will recognize the structure we have here. So A-scene is a scene component in A-frame terms, and it's within that that you'll place your content to appear typically within your VR space for A-frame, but also we'll see now for AR. And indeed, if we look a little bit further down, we'll see here this line is a 3D model. And it's just imported in the usual A-frame way. It's a GLB file, so that's a binary GLTF file. That's a relatively standard 3D model format. And it's just been included, you can see here, alongside my index.html file. And so if I'd placed just this object out here in my scene and I hadn't added anything else, it would be a VR experience with just that helmet rooted in VR space. But in this case, we've added some Zapper magic. So first thing to note is we've added a Zapper camera. Now what this does is turns on the user's camera and asks them permission to access that camera. And it takes the camera frames and places them as the background of your A-frame scene so the user can see what's taking place. Now, in addition, we're adding the user-facing true here, because for this example, we'll be building a face-tracked experience, the same one as we saw a moment ago with the helmet, as the user moves their face around. And because it's a face-tracked experience, we want to use the selfie camera on the device. And so in this case, we've hit pass user-facing true, and that just means that we'll select the camera facing the user. Then we've added an A-entity component here. Now in A-frame terms, that's just a group, if you like. It's a way of containing content, and that content will move, everything within it will move as a child of this entity. And so what we're doing in this case is we're adding the Zapper face component to this entity, and what that says to the Zapper's universal AR library is I'd like to track this entity from the user's head. So any content within this entity will now be tracked and change position depending on the position of my head. I'm also giving it an ID here so that in a moment we'll see there's one element that will mask out the center of my head so that my face appears even though we're putting 3D model in this place. And that's indeed what this line here does. I'm going to comment that out just for the purposes of demonstration first. And then indeed inside this we have our 3D model as we discussed. So hopefully if we give this a try, we'll be able to see that the helmet model will track from the head. So if I save this file here, index.html, I've got a QuickTime player here set up so that I can give it a try on this device that I have here just attached via USB so that we can see it on screen. And if I open up Safari, we'll see here the experience that I have built. I'm going to hit allow on the camera, and we'll see, in this case, my head being tracked in 3D space. I'm just going to reload the page for 1 second because I made a change there to comment out the head mask entry. If I just move this recording over a little bit, we'll be able to see that. You can see here, I commented out this head mask. If I press allow, what we'll see is that my face doesn't appear through here. What in fact we see is the back side of the helmet object, so the back of the internal elements of that helmet 3D model. So what we want to do is mask out my head from that 3D model so that it appears through, and that's exactly what that head mask object does. So if I comment that and hit save, and then I pop back to QuickTime, reload this page, hit allow, then we'll see that my head actually appears in the center of that. The hole has been punched through the back of the 3D model, if you like, so that the camera background appears through, and we have a functioning and usable face filter experience. Great. So I'll just see if I can pop back over to the presentation for a moment here. Just to summarize, that is Zapper and ZapWorks, but more importantly, our new Universal AR SDK that lets you build content using a variety of different creative tools, targeting a very wide distribution mechanism of web, but also native apps, and featuring a ton of computer vision technology, including image tracking, face tracking, and instant world tracking, amongst others. So thank you very much for watching. It would be lovely to answer any questions that you may have.